Dari, good morning. It's Wednesday, the 9th of January. It's way past my bedtime, so I'm going to try and make this fairly brief. Today, I want to talk about logging in the age of home automation. So, the background is that we've moved back from Switzerland to England to a new home, and unfortunately, our new home did not come with home automation as we might have liked. So Agatha and Marcus have set ourselves a task to automate as many things as we can. And we're looking at the situation where an individual home today, perhaps with slightly leading edge, may contain something in the order of 100 computers. And all those computers are producing information, they're producing errors and so forth, on what to do with all that information. So our idea is to take all the information that's produced within a home and store it on one management server, and then we can look at that information on the management server and maybe automate replies or enable us to analyze what's happening. In principle, of course, our solution wants to be scalable because, for example, if you have a second home or another home or even more than two homes, you could, for example, have Internet of Things devices in this other establishment being sent to this management station as well. So we want our solution to be scalable. We certainly want it to be able to deal with at least 100 small computers in one home. And so what do we come up with? Well, I have some props. So just to make things a bit more concrete, I thought I'd bring along a switch. So this is an example of a sun-off light switch. And it's in two components. Let's have a look here. So it's got a relay card here, and it's got an electronics card here, and that kind of clicks together there. And essentially, it's got its own little computer on this one unit, and in fact, it's based on an ESP8266, which I happen to have here. So this is going to be used for another home automation project. But this is a self-contained solution. It's a little computer. It's a light switch, so it's able via its relays to control the power coming in to the power going out. And it's a little computer, and it can have errors. It can have on and off switches. What to do with all this information? So the idea is to automate, certainly centralize all that information. So we've got the following diagram, which is a more detailed diagram. And this video is just a supportive video to the blog post where I'll put down the framework of what we've got as a solution, but it's not fully fledged yet, but it is all working, so we think we can run with it. So if we can start with an easy example, which is our light switch. Our light switch is here. It's running its own operating system, and it wants to write to our management server. So what is our management server? Well, our management server, we've done a lot of research on what we could use. We decided to use a MikroTik router, which is also actually a wireless router and a firewall. We have multiple MikroTik units, but we've decided to use one specifically for pretty much nothing other than the management server. Now, MikroTik will have a free management server called the Dude, and I'm not making this up. And after a lot of research about what we could put the management server on, and on different products, we looked into lots of different products, we selected this device. Now, just heads up for MikroTik, they are a very interesting company, and this is a networking device. So this device can be on 24/7, it doesn't make very much noise, it costs less than £100. The Dude is free on this MikroTik computer effectively, and some of the other solutions we did consider involve, for example, building our own Windows silent fanless PC and installing a syslog server on there. But these devices, or those programs, while they're not free, and then I need to build a separate PC which at best would be fanless, but at worst wouldn't be, and maybe quite noisy. So this is a networking device. It's designed to be on 24/7. The Do program is free, and I would recommend this as a good starting point for a systems management server. So in our example, our light switch or light switches can talk directly to this whole management server. So they can go directly into here. Everything goes via the firewall, so everything goes into the firewall and then into the dude. We have various temperature sensors. They're running under Linux, and Linux has some custom code that we've written under Python, and it used to print out information, and we used to have to go and look at it, or we could log on and have a look at that information. But instead of doing that, we are trying to put everything into system logs, or syslogs as we say in Linux or in Unix. So all Unix computers or Linux computers have something called a system log, a syslog, and applications can write to those system logs. So the idea is that an application that's running on this Raspberry Pi will write to the systems log instead of printing things out of the screen. And then we use another program called an rsyslog D in fact, to take the information from the syslog and transfer it to our dude server, so in other words to the firewall and then to the dude. So that's going in there. Our web server is running Linux, so that's another example of a system which is already writing to the Apache web server will automatically write to the syslog. So we can take the information that's already been put into the syslog via rsyslog and send it into there. We've got things like automated blinds. They're actually controlled by Demotic server. So again, that's running under Linux. And that's using some RF. It's running Arduino, another hardware. So this is running a whole host of hardware, but it's running on a Linux platform again, so it writes to a syslog. And that can automatically be, via the rsyslog, be sent into here. So the blinds actually go into here. Light switches go into here. We have other workstations like Windows workstations or Macs and so forth. Those computers can, via plugins, write to the dude as well. And finally, we have things like storage devices, network-attached storage. Network-attached storage devices have normally got enough intelligence. They're normally based on Linux, but they normally have easy-to-understand GUI panels, and they can also write directly in there. So I think that about sums it up. Yeah, I think I've got a bit more of a detailed diagram on a single machine. So you've got a Linux machine which writes to a syslog. You've got an application which, as normal when it runs, writes to the syslog. The rsyslog program takes the information continuously that's written into the syslog and transports it to the MikroTik device. It comes into the firewall. You need a special firewall rule to get it past the firewall. And then the dude server picks up that information, and one of the functions of the dude server is a syslog server. So the dude server can do many things. It can, for example, scan your entire network and say, I've got these 100 devices. You can also tell it user ID and password information for those devices, and it can go and check things on those devices for you. But generally speaking, all the information is going to be centralized onto this one server, or this one networking device. And then we can use a client. So there's a client which you install on a Windows computer, and that is your gateway, your visual interface to the dude syslog server in this case. So I hope that explains things. As I said, we've got about close to 100 devices, I would say, now in the home, and I think in the future this will be a common requirement. So in the future maybe there'll be more of a standardized solution, but I think for now we're going to have it covered with the dude syslog server. Okay, thanks for watching.